that is the first thing I wanted to mention. Now I think we can get into the business. So let me share my screen first. Okay. Fine. Can you all see the screen?
Yes, sir.
Yes,
Fine.
sir.
Yes, sir.
Fine. Oh, thank you so much. Okay, so as Madam said that I'll be dealing with limits and continuity, of course, of one variable. So of course, I have prepared some list of problems which we will be enjoying, which we'll be discussing together. And I'm sure that many of you have already done enough of problem solving, have done a lot of revision. So what still I plan to do is try to, quickly revise few ideas which usually we might have missed, or some of us might have missed. And then we will get into the actual problem solving. So maybe for 15-20 minutes initial discussion on the topics, the results, all possible results we would like to revise. Interestingly, some counter examples we would like to see, and then get into the actual problem solving. Okay, so this is the idea of these 2 hours session. Okay, so let's begin. um yeah, so as a revision part, I can start with the first and foremost question. I- my pen is not working suddenly. Let me see whether after all the trials still. Yeah, finally. So let us recollect, or I can say revise certain things quickly. So let me take a function from for time being from R to R. Okay, real valued function. Fix up some point, a real number, and let's start with the starting point. That is, if I'm asking limit x goes to p, if I'm saying it is equal to L, then what do we mean by it? What is the meaning of such a such symbols? Okay, so this means something. So who is going to quickly tell me what do you mean by writing something like this, right?
As X goes to P, it's
It
So what do we
the
means the
mean by
value
it?
of function
We
at
all know.
p approximately.
Sorry, no, you're little low. I'm not able to hear you.
Uh, Sir, as x goes to p, then the distance between fx and L would be less than 1 by n, which is called epsilon.
Okay, okay, fine. So he wants to say as. I'll just write what you are saying. You all, anybody can contribute. As x tends to p. Okay, I'm putting it in quotes. Uh, we must have, we must have f of x, distance between f of x. So I'm writing here, f of x and L is something like less than. He's saying less than 1 by n. 1 by n, I don't know from where this comes, or maybe can you modified it immediately. So can I write it is smaller? Maybe it's smaller. Any corrections or any suggestions to this definition?
as the distance between X and P is smaller.
uh, as so this you want to replace by something, distance between x and p is smaller, is becoming smaller. We must have this, we must have distance between fx and L also being smaller, which is fine. That is the intuitively what we mean is something like this. So now, can you give me a more precise version of the definition? So final version of
Sir,
definition.
For
Yes.
epsilon positive, there exists del positive such that
Uh,
modulus of f of x minus L is less than epsilon.
hmm. Okay, let me write. So for all epsilon positive, there
Positive,
exists
there
some
exists
positive
del
real
positive
number such that, yeah.
such that
Now what next?
modulus
Can
of
you
f of
complete?
x
Huh.
minus modulus of f
Of
of
x.
x minus L is minus L
Huh. Huh.
less than epsilon.
Less than epsilon. Okay.
Epsilon whenever
Huh.
modulus of x minus A is less than del.
Okay. Whenever modulus
Modulus x
x minus
minus A is
a,
less than del.
in our case, suppose I'm using symbol p, then p less than
Less
delta.
than del.
Okay. Everyone agrees this is the definition, or somebody still have some modifications to do?
Yes, sir.
Mukesh, yes, tell me. Yes,
Yes, sir. It is the correct definition.
this is correct definition. Okay, okay. Someone else, anyone else who has
that
some
mod x
change?
minus p less than delta should be greater than 0. That mod x minus p should be greater than 0.
Firdos is saying something. She is saying that while writing this, we have to write something like this. Yes. Now, anyone has a objection? ये लिखना, is this needed or this is enough?
No, sir, it is not needed.
It is not needed. Okay. Someone is saying it's not. Arpita, I think, has said it's not needed. Fine. Okay. That is a question. Let us take a poll then. Means who all are saying it is needed? Tell me when then. You can raise your hand or something if that is there as a facility, or you can put in the chat. I can read chats. Needed question is this 0 less than mod x minus p less than delta? This part, is this needed? Is the question. So you can put yes or no in the chat. I want to see. Okay. Okay. Oh, so I'm happy there are both answers which are
Needed, sir.
okay. Someone else said needed. Fine. Why it is needed? If those who are saying needed, can they justify why you need?
Because if the distance is zero, x is equal to p. So if the function is not defined as p, then
Hmm.
that doesn't imply that limit is not does not exist.
Yes.
So
See,
we want to
yes, correct. Mukesh has got the point. So I'll just now elaborate. You are correct, Mukesh. What the point is, see, if function is, can I talk about limit x goes to p fx, even if f is not even defined at p? Can I still talk about such a limit? What do you think, all of you?
Yes,
Yes, we
Yes.
intend to talk. So
yes,
if
sir, we can.
correct, so in that case, I mean, I have to keep my point p outside the discussion, isn't it? Because f of p is not known. So when I put x equal to p, this expression I can't talk about because f of p is not known. So in that sense, whenever you are discussing limit, what happens to the function at a point is not going to affect the existence of the limit. In fact, it need not be considered while discussing limit of a function as x goes to p. And hence, this is the small point one needs to do, which will see if you put this restriction, if you don't put this, then what will happen is you won't be able to discuss certain limits at all. Whereas we want what? We want a definition which is most general. So we would like to cover all those cases also where f of p is not even defined. Still, we are interested to talk about the limit, and hence this is I mean necessary to have a broader definition. Otherwise, the definition will not be even applicable in the cases where f of p is not defined. We don't want that to happen. You understood this point? Small point?
Yes.
Very nice. Good. So that is one thing. So finally, let me erase these things and let's have a final version. Final version, something like this. Very good. So this is our final statement of limit. So when do I say limit f of x as x goes to p is L? When this happens. That is, so basically what I can say is I can draw a figure. This is my domain real number, real line, and this is the kind of codomain real line. And now what you do is you give me any distance, my L minus epsilon to L plus epsilon, however small the distance is, I should be able to adjust over here. I should be able to adjust my distance over here such that whenever x is within this distance, its image should fall within epsilon distance over here. This is the idea. Okay, that is, in other words, the points which are near, very close to P, should have their image very close to L. Fine. Now, before we move further, so limit whenever exist is unique and all those things you all are knowing. I am keen about one more small idea, that is negation. What do I mean by limit x goes to p fx is not equal to L? Can someone directly give me the negation statement?
So
There
there
exists
exists
epsilon.
Okay,
epsilon.
I'll write there exists epsilon. Someone else can continue. Yes.
For
For
which no delta work.
For which no delta works. Yeah, I agree. Now continue with the statement.
For every delta positive such that
For every delta positive, okay, what happens?
Distance between x and p is less than delta, but mod of f of x minus L is greater than or equal to
Okay,
epsilon.
okay, I'll write distance between x and p is less than delta. This is, but distance between fx and L is not less than epsilon. It's greater than or equal to. Is this correct? Or someone has an objection? How many of you are saying it is not correct? Yeah, people can speak yes, correct, or no, not correct.
correct.
Correct. Pratik is incorrect. Anyone else who anyone has an objection? Just tell me. Or everyone takes this as the negation. Such that I did not write such that. Okay. Hmm. All of you take this as the definition. I
Sir,
mean, as the negation. Sorry.
maybe for all x we have to add or something. For all
Okay,
x,
she's now trying to add something. Okay. So should I write for all x also? For all x such that this, but this is not true. Is
Sir,
this what we should?
Sir, there exists delta, I think.
Okay, there exists delta is what Suresh is trying to add up. Okay, someone else? Oh, so this is
Sir, we have functions like mod x for which at particular point zero there exists no limit.
yeah, Ashish, I didn't hear you. What about function like
Modulus of x or absolute value of x.
modulus of x?
Uh, So for
What?
that function
Huh,
at point zero there
at
exists no limit.
point zero there exists no delta. You want to say?
Uh,
Okay. Okay, I'll come to this function when we actually get into the discussion. By the way, mod x is continuous. So mod x, the limit x goes to 0. If you talk about of just mod x, then that exists and it's equal to 0. So this won't create any trouble. There will be delta available for a given epsilon, right? So that won't have trouble. But I'm asking about a general negation. So let me disclose. Understand when we write this. When we write this, what we mean. When we write whenever, what is the meaning of whenever? Whenever ka meaning is for every x satisfying. Okay, for every x satisfying this, we must have this to be true. That's what the statement is. Understand? So I can actually write it more in a, I mean, another order, so that negation will be easier and faster and accurate. So how do I write it? I can write it for every epsilon positive, there must exist some delta. I should be able to adjust some delta such that for every x in the domain with 0 less than mod x minus p less than delta, we must have mod fx minus L less than epsilon. You get my point? And now when you go for negation, it's more clear that, see, I mean, even mechanically we can do, but we understand that this will change to there exists one, at least one element in the domain such that it satisfies this condition, but its image doesn't satisfy the required condition. That's what we mean by no delta works. Is this point clear to all what I'm saying?
Yes.
Yes,
So
sir.
that is again something which one needs to understand, and people miss it out in a hurry. Fine. Now, I think enough time we have just devoted for this. Um, so I can just quickly recall sequential limit, sequential idea, or sequential definition. So what is the sequential definition? I'll just quickly write it. Limit x goes to p fx is equal to L if and only if for every sequence xn converging to p, with of course the assumption that no xn is equal to p, because f of p is not defined. We must have, I'm writing in short, I hope you understand. F of xn, sequence f of xn should converge to L. Okay, that's the sequential, I can say, definition, or people call it as sequential uh, limit, in the sense that whenever the limit exists, you pick up any sequence which is going to p and look at the image sequence f of xn that has to go to corresponding L. This should happen for every sequence, and the converse is also true. Whenever this happens for every such a sequence, that xn goes to p, we have fxn goes to L, we must have the limit existing and it's equal to L. Fine. This everyone knows. But the consequence of it, okay, is if I ask limit x goes to uh, say 0 of fx, where fx is defined as say 1 if x is say rationals, I can say, and -1 when x is irrational. I think everyone is in a position to tell me the answer. What happens to this limit?
Does not exist.
Does
Doesn't
not
exist.
Correct. And you know how to justify it? Correct, correct. Does it exist? Quick justification, one line answer, two lines answer. Why does it not exist?
The value is not unique.
Huh? The value is
Sir, when we
huh,
take two sequence, one is
very good.
from rationals and one is from irrational,
Correct.
then they converge a different limit.
Very good. So you take a sequence xn converging to 0 where this is belonging to rationals, and you take another sequence say yn converging to 0 which is from irrationals. Both sequences will exist. Why? Because of density theorem. Okay. And but then their images. If you look at f of xn, that will converge to 1, and f of yn, that will converge to -1. That means, you cannot have this thing happening, because a hidden statement here is, whenever you have a sequence xn converging to p, the corresponding f of xn is not only convergent, but it converges to same limit. Okay, whereas here we have different limits. Good. There is another interesting function which I'm sure you must have worked out. I just want to mention it. That is sine 1 by x whenever x is non-zero, and say 0 when x is 0. I'm talking about same limit. I want to discuss same limit. What do you think?
Does not exist.
Correct,
Does
Pratik,
not
correct.
exist.
Okay, Tanya, thank you. Correct. And again, you have to pick up sequences to justify it doesn't exist. Pick up the sequences. Sine 1 by x as a oscillating kind of a function, it behaves badly when you take some sequence, say 1 by n pi. If you take that as the sequence xn, sine 1 by n pi, 1 upon 1 by n pi, but that will be 0. And you can adjust a sequence in a way that this answer will be 1. Okay, good. So one more point, because this I need later on, that limit x goes to 0 of sine 1 by x doesn't exist. By the way, understand, limit x goes to any other point of sine 1 by x. Will it exist? Like if I ask limit x goes to 1 of fx, that's going to exist. Fine. Moving ahead, I want to ask one more question. Say, suppose limit x goes to p fx is L. Now I am having another limit y goes to L of gx, gy, I mean. So y goes to this L of gy is m. Then what can you say about this limit? You know what am I going to ask? Can you frame the question?
F plus
Decompose
Correct. I'm going to ask G compose f of x. What do you expect the answer to be? G composed f as x goes to p.
sir,
What
it
do you
is
expect?
if
Uh-huh.
is continuous at L.
Very good, Pratik. This is the point. One expect it to be m, but it's in general not true, is what I'm trying to observe. That although this facility is available for continuous functions, that when f and g are continuous, g of f is continuous. In general, this is not true. You can't say simply by having these two limits, you can't say g of f, the limit is m. It is m when your g needs to be continuous at L. Otherwise, it won't be. I mean, it need not be. Fine. So that is one small observation I wanted to mention over here. Let's go fast to something like continuous functions. So what do you mean by continuity? A function is continuous means what? Continuous at P, suppose I want to say. Function f continuous at P.
For epsilon greater than 0, there exists delta greater than 0
Okay.
depending on
Now I can make help of limit, right?
limit
Limit x goes to
to
P.
p f of x equals to f of p.
Correct. F of P. That's it. Okay. And then, of course, you have epsilon delta definition for limit, which is applicable over here also. So you can always write this in terms of epsilon delta. So when you say this, when you say function is continuous, the limit not only exists, but the answer to the limit should match with the value of the function at point P. Okay, fine. So I think I have covered a few things. Quickly, I'll move to yes, sequential continuity. I don't have to mention, it's available as it is. Two properties I just want to mention. First is intermediate value theorem. So what is it? A simple version can be. So at this point, I just wanted to. Uh, okay, maybe I'll do it later. So what is the version? I can just have a simple version. Take 2 points A and B, A less than B, and at these points, function takes different signs. If f of A is less than 0, f of B is greater than 0. If that is happening and the function is continuous, it has to cut x-axis at least once. This is obvious looking kind of a statement, and it can cut more than once also, of course, but at least once it has to cut. Okay, this is what intermediate value theorem is. And the more general version could be, you take any 2 points A and B, and say, for example, I mean, for convenience, let me take f of A less than f of B. F of B is here. Now you take any k between f and fb, all right, then there always exists some c here such that f of c is k. Why? Because continuity is there, and hence you can just always assure that k has a inverse image, at least one. If the function is behaving differently, I may have more than one, such k values. I mean such c. This is one c, this is another c, this is one more c. All right. So this is intermediate value theorem, a more general version. Uh, Typically, I mean, there are questions asked on intermediate value as well. Okay. Yeah. Moving to the next. You can stop me if you want me to elaborate on something. The next thing I want to talk about is boundedness. See, I'm a little fast because I'm more interested to solve more problems, and I know you too. But I thought some points may be helpful. Yeah, so boundedness again is a interesting point of it. Oh, sorry, before boundedness, one more thing. Intermediate value, I have some consequences. F AB to AB you have, and a function is continuous. Then, can someone say something? You must have seen the result. So, a function is continuous from a closed interval to itself, closed and bounded interval to itself. Then we can say something about the function. Anybody? Yes. I mean, have you seen such a situation? You can say no, so that I know where to. Yeah.
The image of this compact interval under continuous map must be a compact interval.
Right. That I agree. Something more than that, because here we have codomain also something special. So yes, what he said is correct, because this is closed and bounded. It's compact, and its image must be compact under continuous. Yes. Something more than that.
There exists a point in domain whose means f of c is c. Fixed.
I not correct, correct, correct. So what we can say is there is some point between A and B, may be closed also, such that f of c is c. In other words, c is the fixed point. C is one of the fixed points of the function. So if the function is from a closed and bounded interval to itself, and it's continuous, then there always exists a fixed point of that function in this interval. And it's very geometric. I thought you know it, but let me just show you. It's very easy to observe. So you have interval AB to AB. So this is A comma A point, and this is B comma B point, and the whole graph is going to lie in this region only, right? Now you have a line y equal to x, by the way. This is a line y equal to x. Okay. Now if I want to, if f of A is A, A itself is the point C I'm searching for. If f of B is B, we don't have to search for anything else. So let's assume fa is not A. So fa is somewhere here because it must lie between A and B. It must lie between A and B. So fa is somewhere here, fb is somewhere here. And now when you try to join these 2 points, you can see continuity will force us to cut this line at least once, this y equal to x line. And now wherever it cuts, this is the fixed point of the function. Understand? So this is very interesting. Result. It's known as fixed point theorem for R, for real line. And what it says is this. Now my question is, you try to see what happens if we change, say, for example, our say codomain to close A open B, or if we change the intervals to, say, unbounded closed intervals, say closed A to infinity. If we have that to itself continuous, does the result hold? Like that, you can ask questions. You can ask, suppose it is not an interval but a union of two intervals, will the result hold? Okay, this is how one can actually learn more about the behavior of continuity. Fine. So this is a small point. Moving ahead to the last part, that is, I want to talk about uniform continuity. Okay, that's a quick revision. So when I say uniform word, what we mean is the delta that we are trying to find does not depend upon the point. Wherever you are in the domain, same delta should work as far as you are talking about same epsilon. So for that fixed epsilon, for each point on the domain, if you are having same delta working, then function is not only continuous, but it is uniformly continuous. Now, the point I want to emphasize, I'm sorry, is if I'm taking a function fx equal to, say, x square. Okay. Now, please understand what matters is what domain you are talking about. So this is function fx equal to x square. Now, if I'm saying 0 to infinity as my domain, then you take any 2 points over here. Their images are also very much quite close by. But if I take these 2 points, almost same distance with each other, but uh, away from 0, then you see their images ka distance. So you can see the distance between their images has increased. And now as we keep going ahead, although those 2 points are within same distance, the distance between their images will be much higher. And hence, with this understanding, we would like to say for x square, if I am taking the domain at, say, 0 to infinity, it won't remain uniform continuous because we may have to change our delta. You understand this point? Because later on, the delta needs to be more shorter to have the corresponding images close to f of p. Fine. So in that sense, one has to, what matters is the domain also. If I restrict the domain to, say, some bounded intervals, say 0 to 2, whether open, closed, doesn't matter as far as this function is concerned. Now it will be uniformly continuous. So this is one small point I wanted to emphasize on. And now, as he said, if your domain is closed and bounded, that is compact set more generally, and continuity is there, then the function will always become uniformly continuous. So this is one additional thing I just wanted to uh, deal with. I think we'll now start with problem. I'll share the problem sheet by sharing the link. Okay, I'm sharing the link in the chat box. This link is the link to the problem sheet. Please click on the link. If it is not opening, please tell me immediately. It should open, but still. Do you all see the link?
Yes, sir.
Yes, sir.
Very good. Yes, yes. So there are several questions which I have picked from mainly from JAM previous year's question papers. Few from other exams as also there are there. So we'll try to discuss as many as possible. So let me pick up the first question for discussion. Yeah.
Sir, sorry for interrupt.
Yeah,
Can
please.
you explain the boundedness?
Boundedness of okay. So under continuous function. Yes, I'll tell you. Just a moment. So see, point is if you have a function, okay, from R to R and continuous, then this need not imply f is bounded. We have examples because I will simply take f of x is equal to say x square. Then this is not going to be a bounded function if I am taking my domain as reals. But then, so somebody may suggest that don't take reals, take a bounded interval. Say maybe I would like to take open 0, 1 to R and continuous. Now, does it imply f is bounded always? Then again, the answer is no. Answer is no because you have examples. Anybody who can give an example of a function which is not bounded on
One of
this?
1 by
1 by x.
1
Very
by
good.
x.
1 by x. Okay, it's not bounded. Even the interval is bounded, domain is bounded. Whereas if we put a restriction that I am talking about closed and bounded interval to R and function is continuous, then this implies f is bounded. And in fact, because such a strong restriction we had put closed and bounded, it not only gives us boundedness, but it also gives us the existence of or attainment of their maximum and minimum. So f is bounded and its minimum and maximum, or I can write more shortly, it attains its maximum and minimum. Now, what I mean by attains, those who are in TY can definitely tell quickly. What is the meaning of attains? There is a point P and there is a point Q in the domain such that f of P becomes the maximum of P. I mean, I should say supremum, and so it becomes a maximum of F, and G of f of Q is the, so let me be more precise by not mentioning maximum here, attains its supremum. Because it attains its supremum, we can call it as maximum and infimum. You understand? I hope you get my small point what I said. This is say supremum and f of q is infimum of f. In general, supremum and infimum need not be attained by the function. But if you are talking about closed and bounded interval and continuity, will force the function to attain its bounds. So this is what I wanted to say about continuity and boundedness. Huh? Right. Is it fine? Shall we move to?
Yes, sir.
Yeah,
Thank
yeah,
you,
good.
sir.
Yes, yes. So look at the first question. Don't disclose the answer, but I'm curious to know how many of you can manage this question. Which factor needs to be considered? You tell me. Continuity check करनी है. If I want to check the continuity, what about x square? Does it be troublesome?
No, sir.
No.
No.
No, sir.
No, sir.
What about 1 upon 1 plus mod x?
No, sir.
No,
No,
because
sir.
1 plus mod x can never be 0. Whatever your x is, mod x है, so it is always non-negative. Right. So the factor one has to think which may create problem in continuity is floor of sine pi x. That's it. So ultimately, this question is asking for floor of sine pi x. The other two are just to make the expression little complicated. That's it. So let's look at floor of sine pi x. Right. So how this sine pi x behaves, that one has to understand. Quickly. See, if everyone knows the answer, we'll move further because I'm not able to see your faces. I'm not able to uh, decide how much time I should spend. Uh, So if you know the answer, you can just put in the chat. We know I'm done, kind of. If there are many done, I will immediately move on. And if you want me to solve, I will solve. Okay, so uh, keep responding. If you are done, you can immediately write done. So I'll take 10 seconds, 15 seconds pause. Very good, Sunil. Okay. So Arpita, fine. Ashutosh, okay. Okay. So someone can help. Say maybe Shruti would like to tell me not just the answer, but the argument. Yeah, Shruti. Yes. Okay. How about Ashutosh? Would like to. Okay, fine, fine, Shruti. I got it. Ashutosh would like to say the argument. Okay, option one is saying, why is it so? Like, Any reason? Okay, Ashutosh is saying option 1. What about Arpita? What is your option, Arpita? Hmm?
Sir, it's both B and C.
Okay, B and C. Okay, fine. Now who is remaining? Sunil. Yeah, Sunil can also share his answer.
Yes, sir. B and C.
B and C. Okay, okay. Let's see. So let's try it out. Sin pi x, how the graph will look like. Sin pi x. 4 minus 1 1 only we have to think of. So at yeah, can you mute yourself? Someone is fine. So at 0 it's 0. Fine. At half, it is sin pi by 2, which is 1. At 1, it is sin pi, which is again 0. Like that, at minus half, it is minus 1. And at minus pi, I mean at minus 1, I'm sorry. At minus 1, it is 0. So how the sine graph goes? It goes like this. Sin pi x goes, it goes like this. Then we want to look for this, right? So what intervals can we make? You see, sorry, my internet has some issue. Can you hear me?
Yes, sir,
Yes,
you
sir.
are
Yeah,
audible.
fine. Okay. So look at, say, for example, let me look at 0 to half interval for time being. 0 less than or equal to x less than half. At half, at x equal to half, this answer is 1. So this is 1 at half, right? Between 0 and half, the answer is between 0 and 1. This is 1.
It's
So,
0.
so this is 0, right? That means definitely at half, discontinuity is found. Fine.
Yes.
Now, correct. Now, half less than x less than 1. Okay, what is it?
0.
It is again 0 because the value lie between 0 and 1. So it is again 0. And in fact, even at 1, it is 0. So there is no issue at 1. Fine. Now go backward between minus half less than x less than 0. Let me play safe. So at minus half, it is minus 1. So at minus half, it is minus 1. How about minus half and 0? Between minus half and 0, the values are all going to lie between 0 and minus 1. So the floor is minus 1.
Minus 1.
Yes.
So I don't have to treat minus half separately. This is minus 1 throughout. So this is not needed. Now what about minus 1 to minus half? Huh?
At minus 1, it is minus 1.
At minus 1, it is 0.
Sorry. 0,
Correct,
0,
correct.
0.
Fine. So between minus 1 and minus half, again it is minus 1 only. You see that? Minus 1 strictly less than x less than 0, then it is minus 1. And at x equal to minus 1, it is 0. So points of discontinuity कहाँ मिल रहे हैं? तो एक तो -1 पे है, right? because वो change हो रहा है at -1 and after -1 it is -1 up to 0. At 0 it is changing, so this is one more, right? And then at half it is changing. So that is all. Are you getting my point? Is this okay to everybody?
Yes, sir.
Very good, very good. So finally B is the answer. Only B is the answer. It has unique answer. Okay, at minus half, it turns out to be continuous, interestingly. Right, good. Shall we move ahead quickly?
Yes.
Yeah, go ahead. So we can look for, okay, second, if you want, we can. Yes, second, we can try quickly. What do you think you will do for the second?
The second question is not visible.
Is?
Not visible, second question.
Oh, not visible. You can download it from, okay, I'll do it in the soon. Okay, now I have copied it.
Yes, yes.
You can download also the PDF so that you will have the whole list with you. I have shared the link text box, chat box में. So you can keep that with you. Right now you can see it from here. What do you think you should do? Don't be in a hurry to solve. First take 1 2 3 seconds pause. Take understand, maybe 10 seconds.
But find the limit at x equal to x tending to infinity.
Find the limit by what? How do you find the limits? Which rule, which theorem, which result, something you need to apply, or how do you find the limits?
Just by simply putting x equal to infinity, or by
Okay.
separating each of the terms.
Yeah. So when we try to put something like infinity, what happens is it turns out to be infinity into 0. Now infinity into 0, we have no control over that,
L'Hopital rule will.
So now L'Hopital. Now problem is, we can of course try applying L'Hopital, but then you have to keep checking it for fx, then x times fx, then x square times fx, and then x raised to m times fx also. So 4 L'Hopital के questions हो गए ये. So you can try that, of course, and see. Try it out. I'll take 30 seconds pause.
Sir, we put x equals to 1 by t, then take limit t equal to 0, and then it will like 0 by 0 form, then L'Hopital.
Yeah, apply. Yes. Go ahead, Sunil. Yeah, I saw the messages right now. People have responded as L'Hopital. I'm sorry, Malik, and I missed your message. Actually, don't go by the. I mean, if I correct the typo now, it will be a hint, but let me do that. Is slash R. So I can declare there might be multiple answers correct. Anyone who got the answer can.
Sir,
Okay,
if we try by
Ashutosh.
logic,
Huh.
A, B, and C,
Ritvi.
all three are correct.
All are true. You want to say?
Yes.
Yeah, by
So A, B,
L'Hopital.
and C. A, B,
Very
and
good.
C.
Correct. Okay. Fine. Very nice. A, B, and C. All are true. Or D also. Ashutosh, L'Hopital, I'll just tell you quickly. If you have limit x goes to any number or infinity, whatever, x goes to some real number or infinity of fx upon gx. If you have this, where this limit as x goes to p fx is infinity and this is also infinity, x goes to p gx or 0 by 0. And if limit x goes to p of f ka derivative of f and derivative of g, if this limit exists, then answer to this limit is equal to answer to this limit. That's what L'Hopital rule says. Okay. Yeah, Jyoti is saying all options. Tanya said all options. Maria said all BCD. Okay, good. So I'm happy people are answering almost correct question, correct thing. Interestingly, all options are correct. Now, whichever way you want to handle this, you can handle. Of course, L'Hopital is there, which helps. Or another way is you try to express. We know e raised to x has got some series expansion. So I can just write it as e raised to 1 by x cube. What is e raised to x expansion? E raised to x 1 plus x square by 2 factorial plus and so on. So if I write e raised to 1 by x cube, it will turn out to be 1 plus 1 by x cube plus 1 by x raised to 6 into 2 factorial 1 by x raised to 9 into 6. I mean 6 in the sense 3 factorial and so on. Now when we subtract 1, e raised to 1 by x cube minus 1 plus 1 by x cube times x, what this expression will turn out to be? This 1 will go. So you are left with 1 by x cube plus 1 by 2 by x cube upon x, that is 2 by x square plus now 1 by 2 into x raised to 6, 5 plus 1 by x raised to 8, 3 factorial and so on. Now when you try to take limit x goes to infinity of this, that uniform convergence will allow you to take individual limits. X goes to infinity of this, x goes to infinity of this and so on. And now all of them have got x in the denominator and we are safe. So limit will exist. So this limit will exist. In fact, multiplying by x, that is x square will come here. That also won't spoil the argument. So even this will exist. X square multiplying also will do. But if you multiply by x cube, okay, then there will be a problem. And so D also will be true, because m equal to in fact 3 will create a problem. Limit won't exist because x will appear in the numerator for the of the first term. And so extends to infinity of 2x will create a problem. This is one other just idea. I don't mind. You can solve it at your convenient way. L'Hopital is certainly helpful. Chahe aage, I'll move fast to next. Is this fine? Anyone has any doubt? Please ask. Others can certainly move ahead. They don't have to wait for my signal. Those who are done can move to. You can even. Okay, I can't discuss all the problems. So let me be little choosy about third. You want me to discuss third? Yeah, can you put in the chat? Do you want me to discuss? हाँ.
यस सर, इसका जो फर्स्ट ऑप्शन है वो आप कर दीजिए, क्योंकि ये कॉन्टिन्यूटी वाला पार्ट तो हो गया कि ये उस पे कॉन्टिन्यूस नहीं होगा रैशनल पे, बट वो स्ट्रिक्ट मिनिमा वाला थोड़ा उसमें कंफ्यूजन है.
हाँ. Okay. Right. Let's see. So let me. Oh, I did not put it on the open board. I'll put it quickly. So we'll do a little fast. Here it is. So see, this is a very standard function, popcorn function we call it as, or Thome's function का ही version है. Now, how does it behave? How does it behave? That we'll see quickly, and that will make it very clear. So, how does it behave? I can just draw a line. Okay, and at every irrational, it is 1. So, of course, at 0 also it is given as 1. By the way, I'm sorry for the typo. You have one has to put this bracket. Please do that. If x belongs to r minus q, union with 0. So at 0 also it is 1. That is a typing mistake. Please, everybody. Huh? So at 0 it is 1. And at every irrational it is 1. That is first thing. Now at every rational, say for example, if I'm looking even at 1, what will happen? How much is the value at 1? 1
0.
can be written as 1 by 1, correct. So it is 1 minus 1. So at 1, it is 0. Let me draw it in a. Okay. Now at 1 by 2, how much is the value?
1 by 2.
1 minus 1 by 2, that is 1 by 2. Okay. So this is half. Now one can look at, say, something like 1 by 3 and 2 by 3. 1 by 3 and 2 by 3. All right. At both these, the values are 1 by 3, 1 by 3. Do you agree? We are removing the numerator and keeping only the, not 1 by 3, 2 by 3 and 2 by 3. 1 minus 1 by 3, 1 minus 1 by 3. So let me make it as it is minus. So we'll go upward. That is something like 1 by 1 minus 1 by 3. So 2 by 3 and 2 by 3. Everyone get it? Now if you look at 1 by 4, 1 by 2 forget, and 3 by 4, the image will be 1 by 4. So 1 by 4 and 1
3
by
by
4.
4.
Sorry, 3 by 4. Image will be 3 by 4. Correct. 1 minus 1 by 4, that is 3 by 4. Like that. Now at 1 by 5, it will be 1 minus 1 by 5. So something 4 by 5 will appear 4 places. 1 by 5, then 2 by 5, 3 by 5, and 4 by 5. That is how now I'm just approximately plotting the dots. You are you getting this?
Doctor.
Like that, you will have the dots. Uh, can you mute yourself, please? Huh. Is this clear? So at every, I mean, rational, few dots are going to come. Like if I'm talking about denominator, fixing it as 5, then 1 by 5, 2 by 5, 3 by 5, 4 by 5. All these 4 dots will appear in a same line. Okay, above the previous images. Above the previous images. Matlab previous denominators के images. Then if you take upon 6, then all those dots which are not covered will appear over above them. So do you see that local minimum is not an issue because they are all discrete dots? You got it? And so you can always find some kind of a interval, very small interval, in which all other dots are going up. So in that neighborhood, that particular dot will behave like a minimum. The remaining will go up. Got it? Of course, I'm not proving it. I'm just trying to explain the behavior of the function on at rationals. So at every other rational other than 0, the function is going to, because these are going to come something like dots, discrete kind of a picture, you can always choose some interval, very smaller interval, depending upon where you are. In general, n by p, if you take, you can choose some interval such that all other dots will remain above. That is possible. Are you getting convinced by what I'm saying?
Yes, sir.
Precise proof will take a lot of energy, in the sense you have to use Archimedean property to construct such a radius, but it can be constructed. Huh? So this is true. This is very much true. And the other things are not true. Okay, it is not continuous at all rationals, uh, which is not true. F is not continuous at all irrationals is not true. Actually, F is continuous at every irrational. In fact, it is also continuous at 0, because at 0 it is defined as 1. So if you take any neighborhood of 1, you will always find many images and very few images of rationals. Sorry, all the images of rationals also in the neighborhood. Such neighborhood can be obtained. Because after some stage, all the images of rationals are also reaching to 1. Do you see this point? That's the idea. Okay, so answer is A.
Yes, sir.
And not BCD. BCD all are not true. Good. Let's move ahead. I think fourth I can put on you. Fifth, although it is interesting, okay, I'll do one thing. I'll take the whole sheet over here and so that it will be easy for us to discuss. Yeah, can you now see all the questions? So fifth one, uh, you can manage. Can someone quickly give the answer? Fifth.
C.
Okay. In which of the following cases there is no continuous function? Okay. One answer is C. Any other answer anyone else wants to say?
Option C.
Option C again. Fine. I'll.
A.
Okay, one more answer, which is good. So one answer is saying C. Another answer is A. There is a clash now. So I suppose it has unique answer. So someone said A. Why it is A? You feel why A is the answer?
Because sir, to we have to make onto
Correct. On 2, and image of this has to be closed and bounded interval.
Yes, sir. A option B.
So A is because T are real numbers is not closed and bounded interval. That means this is not possible. Okay, image of closed and bounded interval must be closed and bounded interval. Right. ये statement में मैं दोनों बातें use कर रहा हूँ. I'm using both the things. One, intermediate value theorem also is being used when we say closed and bounded interval. But anyway, so this is definitely not continuous. There is no continuous function exists. But then, it's a nice exercise to actually confirm that B, C, and D, there you can find some continuous function from S to T, which is on to. So try that. Not now, maybe later on. It is interesting, nice exercise, joyful exercise of constructing a function, continuous function from S to T onto function. Continuous onto. Okay, fine. So this is the only correct answer. Let me declare it again. Okay, I didn't get you. Sorry, Shruti. Yeah, I can't see the chats parallelly, so that is my problem. Yeah, fine. Shall we move fast to the next? So I'll go to previous. Yeah, I'm not now going to discuss 6th, 7th, 8th. I will not discuss. Even 9th is simply L'Hopital rule. So we can go ahead and go to the further questions. Say 10th. Yeah, 10th we can go fast. Someone can quickly tell me the answer for 10th. Tenth is easy.
It's root 3.
It's root 3. Very good. Because yes, very good, very good. So right, I think others can justify why is it so. When a function is, see, when two functions match at rationals and they are continuous, they match on reals. So if fx is root 3 constant on rational, fx is root 3 everywhere. So even at root 3, it is root 3. Same thing is going to happen to gx. Gx is 0 at irrationals. That means it is 0 throughout. So g of 0 is also going to be 0. So the answer is root 3, which is correct. 11th is computational. You compute actually fs and try to answer this. So I'm not going. Yeah, Komal, which result? Okay, the result is when two functions are same, when fx is equal to gx on q and fg from R to R continuous implies fx is equal to gx on R, and this q can be replaced by R minus q also. Same result is available. In fact, a more general version is, those who are in TY can understand, if fx is equal to gx on some set A, which is dense in R, and f and g are continuous, then fx equal to gx on R.
Okay, sir. Thank you.
So q and R minus q are dense. Yeah, correct. Good. Okay, fine. So which one to pick up? Let's look at 15th. Time is running a bit. We can this is the question. Okay, let me see the chat. Okay, Malik has said D. Ashutosh is saying A. Fine. That is 2. Ashutosh is saying 2. Fine. Any other answers? So it has unique answer, by the way. Okay, Shruti is saying 2. Yeah, Darshika, you want to answer? A3. A has got more poles. I mean, fine. Many A are there. Okay. So I'm happy that I took this question. You know, why am I saying this statement?
Option A
Okay.
might be wrong.
Correct. Kalaya Rasi is saying C. Can you justify Kalaya Rasi?
F of x is equal to x minus x
Correct.
mod x minus mod x.
Very good. That's done. She has finished the solution. See, there are 4 functions. See, interestingly, when I say fx square is x square, that means, I'm sorry, let me write. When we say this, we mean fx is equal to something like plus or minus x. So now, I mean, either fx equal to x or fx equal to minus x. That is fine. That is, these are 2 different functions that you will be getting. But it may happen that, so I have one more like this. This is okay. But why not one side this and other side this? Or why not one side this and the other side this? This is also possible, isn't it? Still, it will satisfy the condition. Good. So 4 is the answer. Infinite is again not possible because you want continuity. Right. So check that out. And the answer is 4. Good, good. Look at, yeah, 18 is also a good question. Try it out. Question number 18, I'll just paste it in the on the next page. Yeah.
Both are true.
Both P and Q are true, you mean?
Yes, sir.
Okay, fine, good. Let people think. I'll wait for some more seconds. Okay, Maria is saying D is true. P is false. Mhm. Okay, good. I have two answers, A and D. Okay. Now Malik is saying B. Fine. So who has answered A can, okay, B is okay. So can someone justify why D is not true? It's correct. A is correct answer. I can just declare that. But then one needs to produce examples for why P is true and why Q is true. With little efforts, one can produce. So F continuous and G not continuous, but G composite F becomes continuous.
Sir,
Sir, something Dirichlet type function, yani branch function.
Okay. G should be a branch function or hmm? Suppose I take this 6 not equal to 1 and say 6 if x is 1. And let me take fx. You want f to be continuous at 1. Okay. Hmm.
Mod x minus 1.
Okay, I take fx equal to x for all x. Does that, what will be g composite f? I don't know, I'm just trying. G composite f of x will be what? If x is not equal to its identity, so it's still 5 and 6. I want continuity at 1, so that won't work. Okay. Uh, what work? Something else?
Sir, I have an
Yeah,
example.
please say.
I got the example f of x as x minus 1 modulus of x minus 1.
Okay, f of x as modulus
X
x
minus
minus
1.
1. Fine.
And then g of x as the reciprocal of mod x minus 1.
1 upon mod.
Yeah.
This only
Um.
or mod x minus 1. What do you want?
Yeah. It's a branch function. At 1, it will be 0.
Okay, fine. Fine. Now, so G is not continuous at 1, correct? Now, when you go for G compose F, what happens to it? Uh, G compose F, not G into F. Fine. So, when you compose, what is going to happen?
It will be 1 upon
Uh,
1 upon modulus of x modulus again modulus of x minus 1 modulus
okay.
minus 1 when x not equals to 1
Hmm.
and it will be 0 when x is equal to 1. It will be 1.
This will be 0.
Sorry, it will be
G compo. Okay, so f of
I'm a little bit confused. Let me check.
confusing. Mm, yes. Anyone else who got the answer? Hmm? This is apparently easy. I think you will be able to get the examples.
Sir, it will be 0 at x is equal to 0 and x is equal to 2.
What function? Where should I change?
The branch function
Here.
g of
Okay.
x.
Tell me. At 1, it has no issue.
Okay, I'm going to change the graph of
Ah,
x when x not equal to 0 to x is not equal to 0 and x not equal to 2. I guess.
okay. That won't.
I
Mm,
think I'm making
mhm.
some mistake.
Fine, no problem. You can make mistakes. It's fine. So maybe you work it out again, and meanwhile we'll
Okay. Okay, sir.
do something else. Fine,
Thank you. Yeah.
Arpita? Yes, fine.
Thank you.
So right now I'm re-erasing, but I'm sure you will get it. No problem. Yeah, so I'm see, due to time constraint, I'm just going little fast. Uh, if you are not able to construct, we are going to meet again. At that time, I will give you the. I'm sure you will be able to construct the examples. It's not a problem. So answer is both P and Q are true. That's the correct answer. For each one of them, you can construct the example definitely. Okay. Uh, I just wish to discuss 21st is something nice, useful. So let's discuss 21. Sorry. Look at 21st, everyone. And don't disclose the answer for now. You know, this question is on what?
Intermediate value property.
Good. So, can someone throw some light? Very nice. One. So, see, this is arithmetic mean, which always lies between f0 and f1. It's going to lie between f0 and f1, and hence that will be attained by intermediate value theorem. You get it? Then same thing, this is geometric mean of f of minus 1 and f of 1. So it is going to lie between f of minus 1 and f of 1. So it will be attained. So this is also true. A is true. We are searching for something which is not true. So A is true, B is also true. Someone said C is not true. Fine. Why D should be true? Can someone prove D?
Sir, Riemann integrable.
Yeah, Riemann integrable is fine. So what do you mean by that? Like, why then C is not true? For C also Riemann integration can be used, no? Exponential function,
Sir,
Malik,
C is not
means
true because area can be negative in C.
area can be negative. Okay. Uh, right. So for 0 to 1 it cannot be. That I agree. But how does that guarantee that it is attained? Got it? See, this is a positive quantity, that I understand. I mean non-negative at least. But does that mean it will be attained by the function? There will be some x such that fx is that answer. It's not told that it is onto function or something. So you are correct. Means it can be negative, area can be negative. Means we are done. But if it is a multiple correct, it may have a problem of D also. Means why D is true then? Anyone? See, okay, let me. Anyone is trying or should I disclose? Just tell me. May I explain why D is not, why D is true?
Yes, sir.
Okay, okay. Let's see. So, see, let's look at a function, same function, only I'm looking at this to 0 infinity. Let us restrict the domain to close 0 1. Now, continuity will tell me that f attains its bounds. So, there will be some small m, which is, I mean, f is bounded, is first thing, less than or equal to fx, less than or equal to some capital M, which is infimum and supremum. In between that only fx will lie over this interval. In fact, this small m can be replaced by some f of p less than or equal to fx less than or equal to some f of q for some p and q in 0 1. That we know. Okay. Now you integrate over 0 1. Integrate over 0 1. Integrate over 0 1. What you get is this is a constant. So you get f of p less or equal to integral 0 1 fx dx less or equal to f of q. So you got a real number between fp and fq. That means it will be attained by intermediate value property. Is that okay?
Yes.
See,
Yes, sir.
as a passing remark, I must say there is nothing great about this argument. In general, if small m and capital M are the bounds, then we can always say that uh, small m less or equal to integral a to b fx dx upon b minus a less or equal to capital M. We can always say that by same point. And then this will be whenever we are talking about closed and bounded interval. So small m, capital M are attained, and hence this will be attained basically more generally. Okay, there exists some C such that f of c times b minus a is equal to this integral of the function over the interval AP. Fine, good. So I'm just going ahead. So is the answer to this is C, and that is the only answer. Move to next. Uh, yeah, yeah. Even 23 is good to discuss. 20. Wait, I'm 22 is L'Hopital. I hope you can try that and find the answer. Can you handle 22? Then we can look for 23.
Yes, sir.
Yeah. So let's see 23. Yes. So you can try. Meanwhile, I'll also try to plot. Yes. Anybody who got the answer? Mm. Simply plot will give you the answer. Anyone?
A.
Okay. A. A is the answer. F is 1 1 on 2. Fine. That is the only answer, or B, C, D में से भी?
Sir, D also.
D also. Pratik is saying D also. Okay, Ashutosh is saying C. Yeah, Ashutosh, fx equal to x is continuous, but when we talk about this interval as the domain, problem is we have to see the nearby points also, na? So nearby points, there are irrationals which will take the function somewhere else. That is the problem. Understand? So even at any rational, so on rational, I'll just plot the point. On rationals, it is fx equal to x, kind of this dotted line. These are images of all rational numbers between 0 and 1. Okay, this is done. Another is x plus 2 by 3 when we are between 0 and 1 by 3. So maybe although 0 is not a irrational, I'll just, to draw this line, I'm just considering the point as at 0 it is 2 by 3 and at 1 by 3 it is 1. So this is the dotted line, and these are images of what? All irrationals between 0 and 1 by 3, right? And from 1 by 3 to 1, x minus 1 by 3. So kind of at 1 by 3 it is 0. Of course, at 1 by 3 this is not applicable, but just to plot the line, and at 1 it will be 1 minus 1 by 3, it is like 2 by 3. So somewhere here. So you are just going to go with this line, right? Okay. So at least what we can figure out is function is discontinuous everywhere, because you take any point, whether it is rational, if it is rational, its image is over here. But then irrationals, the images are very far from this. So you can always find an epsilon where there is no image of irrational appear in that neighborhood. So it's a problem. No delta works. If it is, sorry.
Sir, can you hear me?
Yeah, I can hear you, Komal. Tell me.
Sir, maybe the F is not injective.
Yeah, I'll discuss one on two. Yes, but first I'm just trying to discuss continuity. So, function is discontinuous everywhere. Are you all convinced with this statement? It's discontinuous everywhere on 0, 1. Is that clear? Because you take any point. If it is rational, it is over here, but nearby there are irrationals whose images are above, very much far. So in that sense, it is discontinuous everywhere. First thing. Now we have to see 1, 1 on 2. Okay. Now, how do you confirm that?
So sorry, I thought that f of x
Ah.
is x is for whole x in 0 and 1. I did not see that rationals.
Fine, fine. So, uh, is this point clear to everyone? It's going to be now, is it on to first of all? You take any irrational
Yes, sir.
between 0 and 1? Yes. Then its image can be either found over here or over here. Understood? So definitely, so between 2 by 3 and 1, if there is any irrational, then its image can be found between 0 and 1 by 3. Pre-image, I mean. And if you take any irrational between 0 and 2 by 3, its pre-image can be found between 1 by 3 and 1. It's clear from the picture. And rationals, the pre-image is itself, because fx is x. So on2 is there. And 1 1ness is also means visible. I suppose you can see 1 1. There is no clash. Two elements have same image, won't happen. Okay, that care has been taken by taking these two different lines.
Yes,
Okay.
sir.
So A is also true. So the correct answers are A and D. Okay. Let's make a move to another question. You can try 26, 27, 28, and 30. Anyone? Look at 26.
Said 27.
Okay, 27. Let's look at 27. I'll put it on the new page. Uh, Others can try 26 also. Means it's open to everyone. Anyone can keep playing with any question. It's fine. I'm dealing with 27 now. Okay. Let's see what the question is. Hmm. Mhm. So what do you think is going to happen to this? B and D, Maria has already said some answers. Yes. Why does it not exist? Someone can throw some light. A and D. Shruti is saying A and D. Okay. Limit will exist. Fine. So, what will be the limit? Any answer, Shruti? Limit extends to infinity fx. Hmm.
B and D.
Okay, B and D is the answer. Understand, at every, see, smallest prime we are seeing. So at every even natural number, this is 2. Got it? So as x tends to infinity fx, problem is at every even integer it will become 2. But otherwise it will become larger and larger for every prime. Because if n is prime, then f of p is p itself. So it won't exist because it will go up, function will go up, then again it has to come to 2. Go up, it has to come to 2 again. That way, at every alternate integer, basically at every even integer, it has to become 2. So this is correct. And then many of you are already confirmed with D as the correct answer. Okay, so that is fine. That is good. Fine. So we can make a move to something else. Shall we try 28 and 30? Let's keep an eye on the time. 5 minutes. Yeah. So 28 and 30 we can try.
Yes, sir. 28.
Yeah. Okay, 28. 28 is again plotting what we did to the first question. Same treatment. We have to give little carefully to this question. Just try to draw the graph. Now this everybody should be able to get answer, correct answer. Huh? Hmm. Some of you are saying answer as D very fast. This is from the latest paper, by the way. For those who don't know, I can just 2024 only, I think. Last year's paper. So, yes, all of you are uh, confirming the answer. It is D. It is correct. And those 6 elements can be actually listed. You can check out which 6 elements where it is. See, what happens basically is x minus floor x. How does it behave? It behave as I have to be choosy about my color. So x minus floor x goes like this. At every integer it is 0, and then it will be like x, same angle. So at -1 also it is 0, and then it will go like this. This is x minus floor x. But now y equal to x, you are trying to take the minimum of x minus floor x and x. So x is this. So at any point, when you try to take the minimum, what will happen is, so now let me draw a green color. So between 0 and 1, the minimum is this itself. Means both are matching only. Between 1 and 2, the minimum is this x minus floor x. X minus floor x is the minimum. Whereas between -1 and 0, the minimum is this line. And in fact, throughout the minimum is this line only. Understand? And so up to 1, sign has no problem. Then we just have to check up to 2 pi, between 0 to 2 pi, how many such integers are there? And that is 6. And so the answer is S has 6 elements at exactly 6 points. Because up to 1 there is no issue. The sine curve will, sine of this will be simply sine x up to 1. After 1, it is going to become discontinuous. Sine of this is something like sine x curve you will have, and you will be having discontinuities at every integer up to 2 pi. And hence the answer is D. Very good. Correct. Last one, 30. Any answer to this?
A.
A. F plus G can be continuous is one answer. Any other answer? B. Shruti is saying B with a question mark. Okay, fine. Okay, I think there is some time limit. So I'll just take 2 minutes more. See, F plus G, if I want to say it's continuous, if F plus G is becoming continuous, then F plus G minus F also should be continuous, but that will force G to be continuous, whereas G is discontinuous. So A is not true. But then by the same logic, B must be true, because if F minus G ever becomes continuous, then F minus G and then minus F into -1, you can say, becomes continuous, but that will force G to be continuous. So F minus G can never be continuous. then FG can never be continuous at C. Do you see that? Again, that is to be understood. That is only when F is non-zero. Understand? Because otherwise same logic can be applied. Like Fg is continuous, then Fg upon F, which is G, which is also going to be continuous by algebra of continuous functions. But for that I need F to be non-zero. So that is not given. Understand? So you can't say this. Fg can be continuous. I mean, I'll take F equal to 0 function. Then F into G will be continuous. Composite, of course, you can't guarantee. If F compose G is always continuous, that you can't say. It may be continuous, but not always. Okay, fine. This quote I just wanted to show you. It is important quote that you can read even later. Almost was a great mathematician, and what I wanted to say by this is, I mean, what almost wanted to say rather is, you know, keep keep working with examples. Keep working with more examples. It's not just because through those only a theorem comes. A, a concrete theorem appears when you try to work out several examples. So working out examples is extremely important. Okay, fine. I think I have already exceeded my time. So let us stop. Should I stop screen sharing if you allow every one of you?
Yes,
So
sir.
I stop sharing. We'll be meeting again on 13th. I'll be discussing differentiability. Okay. Yeah. Bye bye. Bye everyone.
Thank you so much, sir, for your valuable time.
Yeah. Thanks. It's my pleasure.
Yes. Participant, your next session is on Sunday, which will be in two shift. Morning session will be from 11 a.m. to 1 p.m. and the afternoon session will be from 2 p.m. to 3 p.m. I hope everybody have no doubt regarding Sunday. Tomorrow we didn't have any session. We have session directly on Sunday.
What's
Okay.
the time? What's the timing for morning?
Morning is 11 a.m. to 1 p.m. and the afternoon is from 2 p.m. to 3 p.m.
Okay,
Okay.
thank you.
Thank you.
Ma'am,
Stay
can you
connected.
tell me one more time?
Morning session will be from 11 a.m. to 1 p.m. Afternoon session will be from 2 p.m. to 3 p.m.
Thank you, ma'am. Thank you, ma'am.
Yes. Thank you so much.
Yeah. May I leave?
Yes, sir. Thank you so much, sir.
Yeah. Thank
Ma'am,
you.
is it fine to not attend that class because the mathematics competition is also at that time on
It
this
is up
day?
to you. It is up to you, dear. It is up to you.
Okay. Thank you, ma'am.
Okay.
Yeah. Bye. Bye, Bridgie, Tina. Bye, everyone.
Thank you, sir.
Thank you, sir, for the session.
Yeah. It's my pleasure. Bye.